Hello and welcome back to the Stearns Stereophonic preamplifier part 5. Although the subjects covered in this video don't have any relevance to the actual preamp itself, it sort of shows my floundering about and trying to get a circuit that I just found on the internet to work without really knowing what the hell I was doing. But then I learnt sort of stuff, and it may help you when you're trying to prototype circuits in the future. Onwards. So why are we getting so little out? Where are we? Where's my finger? This resistor here. This basically sets the input impedance, which is very low, 5k6. If we was to connect this to the output of the preamp, yeah, it wouldn't be, we'd get bugger all out. So we need to increase the value of these resistors here while sort of keeping their ratio, as it were. So we just had a few zeros on the end, so instead of a 470 ohm we'll try a 47k, and instead of a 5k6 we'll try a 560k and see what happens then. Well, I've got more output, but it ain't a lot. I'm now getting 0.37 volts RMS, which has gone up a bit as mentioned. However, well, that's into a 20k load, as it were. Yeah, I've sort of mucked about with the resistors that set the base voltage. It's very sensitive. As you can see, it's either working or not. Right, so I'm just pissing about with a pot here. Oh, and now I've killed it altogether. Oh dear. What have I done there? Horse biscuits. Yeah, a bit of a test equipment snafu. If I just, I'll show you, look. Let's see if we can show you all in one. No, right, we've got to zoom back. Come on, operator. It's not going to do it now, is it? What a swine. Earlier on, yeah, go figure. Anyway, where was we? See how high how an input it can handle. Amplitude 2 volts. Starts to get cut off there, which is not good. So 2 volts in, we're getting 0.6 volts out. Amplitude 3 volts. Amplitude 5 volts. Very, very touchy and sensitive. I suspect that is the power supply. There we go. So with 15 volts, yeah, with 15 volts for custody. My device, my signal generator in a HP 8903B doesn't go any higher than 5 volts. So it looks like I've still got some work to do on this, and I've got the boffins working on it as well, who know a lot more about these 3-legged fuses than I do. Right, there's another job we've got to do while I'm waiting for the boffins to get back for me, and that is to make the crowbar circuit. It makes a change from all this soldering and mucking about with valves. Right, after conversing with the boffins, I realise I've gone off on a totally half-cocked journey with this thing. So for a start, a BD139 isn't a good choice for this application because it has a too lower HFE. HFE is current gain, and I forgot this when taking into consideration our input impedance, because not only does the, there's me thing gone, as the lads kindly informed me, and I forgot all about this. I mean, I've done calculations, whoa, regarding valves, gain. It's all about gain. In valves, you have to take into consideration the gain of the valve, or its U, or whatever you like to call it. Anyway, back to the circuit in question. These are wrong. They should be about equal. This one may be a little bit higher. So my last experiment with the 100k pot in series with a 100k resistor and a 100k here. So I had a 100k and a 100k pot in this sort of position. 100k here was on the right course. Also, this resistor here, our emitter resistor, also affects the input impedance, because essentially these resistors here are in parallel, and I think also from what the chaps were telling me that these are in parallel, although it doesn't look it. But if I was to draw this out into an equivalent Phenobin circuit, sorry, I couldn't stop Phenobin in there. Yes, it would probably tell us a lot more, but I can't be asked to do that. And yes, PD139 out. I've got some little Darlingtons ZCX605s, or I have these, which are probably a little bit overkill for the job, which are MGF 122G, which is also a Darlington. I think essentially it's the same as a tip 122CG or whatever. Right, let's crack on, get this done. Zoom! Calm, you bugger, where are you going? Oh, you... Right, not much glare in here. Okie doke. Voila, that's the output now. I've made no changes. I just basically unplugged the BD139, put in an MGF 122G, and our output now is 0.986 volts, which is a lot better than our 0.4. Just have a look at the... Okay, and our THD has gone up a bit. I'm just going to fart about with the pot, see if it alters the THD. A bit hard to tell, it's jumping about too much. And I also noticed that it's not as sensitive as the BD139 was as regards the biasing. And so let's just chuck in 5 volts for a laugh. Amplitude 5 volts, and everything's cushy there too. Right, we've got 4.86 out. Let's just muck about with the frequency. Frequency 100 hertz. Yeah, lovely. Frequency 20 kilohertz. Ooh, okay, we've got a little bit of silliness there, which is not good, is it? Just mucking about with the bias. Ooh, look, see the bias there? That's just me mucking about with the bias. Isn't that weird? Ugh, it's like a sort of wiggly go-go dancer thing. Right, well, F knows what that's all about. Right, yeah, can't stop doing that now. And let's just go a little bit higher, shall we, just for our frequency 50 kilohertz. And our frequency is starting to go down, but that could be basically down to our capacitors that we're using for the input and output, and I just pulled out whatever value I had to hand in my drawer of bits. Right, I'm happy with that. So I'm not going to play with that anymore. I'm going to crack on with the where do you call it, crowbar. That's pretty straightforward, shouldn't have any hiccups there. Get that sorted, then I've got to have a bit of a tidy and yeah, just a bit of a tidy, and then I can drop back onto the preamplifier which is sitting over there. Focus! Right, it's about 3 o'clock, day's gone by, had to do loads of shopping and crap like that. Whoops. So I need to build one of them. Pretty simple. This is a crowbar circuit, and for those of you who don't know, this is for the heater supply. So the heater supply will be attached across that. That goes out to our preamplifier, and what this does is a protection circuit, so that if the voltage of the heater supply going to the heaters exceeds about, let's say, 6.3 6.4 volts, or maybe a bit more, then this will turn this thyristor on, causing a short circuit across the rails here, and that will blow the fuse and thus protect our valves. I've got various offcuts of what do you call it, copper clad board as I call it, and so it should be a pretty simple straightforward thing to just knock up that circuit on there. Recently bought some what are they, C106D thyristors. Keep getting triacs and thyristors mixed up, and thyrotrons, don't forget thyrotrons. Yeah, so let's crack on, get this little job done, and then tomorrow we can crack on with sorting all the AC RIAA sort of bits of the preamplifier out. So I've started on the, well, it's not a printed circuit, I started on the circuit board, the C106D. If I can get the fucker in the hole, we'll go like that. And then now I need to swivel you. That will go in there. So the thyristor will go in there, and then I have to be really canny and try and keep all this circuit board as small as possible. Sometimes for more complex circuits I will draw a rough plan out, but in this case I'm winging it. So I've got my components, there's not many, of which I keep losing them. We've got that 100 ohm resistor which goes to the gate. This is the gate, so it's a mnemonic CAG, cathode anode gate. So that has to go there at some point over to there, but then that needs to go through this 100 ohm resistor. The resistor isn't essential, but it just stops the thyristor from false triggering, as does the capacitor. Smooths out the bumps, as it were. So yeah, I'm gonna have to think about it. My brain's really slow at this time of day. So that drops the voltage, this 1K5 resistor drops the voltage, or limits, should I say, the current through the Zener. In this case I've gone for a 7.5 volt Zener rather than a 6.2 volt Zener and a normal diode to give us about whatever 6.5 volts. If a fault occurs, then this will trigger fast enough. In the past I've breadboarded this circuit, tested the yin yang out of it and all that, but in this case it's like a once in a blue moon sort of fault that will do the job. The little crowbar circuit is built down there. I'll zoom you in. It's all very small. Most of it is surface mount, as you can see. I'll show you where that goes in a minute. Now let's have a look at the meter. I've just got it on a current limited power supply at the moment for the purpose of testing. Okay, still not fired at 7.6. Just jack it up a little bit. 6. Oh, let's try that. There we go. So it's about 7.9 volt. 7.9 volts it fires, which is fine, because if there is a situation where the series pass resistors on the heater circuit go open circuit, or short circuit, then this little crowbar circuit will see about 15 volts bang straight away, so that'll fire. I'm pretty damn certain that that will work, and I know from testing them in the past in actual heater circuits and everything that they do work. Right, let's show you where it goes. I don't know whether that's focusing too well. That will fit in there. There, fiddle it, just something like that, and those two leads will go across the power supply rails. Just installing the plug on the power supply, and I did it as best I could according to all the regs. Live's got to be the shortest one there, so if it gets pulled out then it cuts the live supply. However, just notice this nick in the insulation there on the earth, and a bit of wire poking out of the live. I'm not happy with that. I dare say I could bung a bit of heat shrink on there or something, and it probably doesn't matter. Let's do the bugger properly. Start again. So after having cut mains cable for years with a knife like that, trying to not nick the insulators, and that isn't a cut there, I took a different approach and just run the knife gently down the insulation there and see if we can do it this way. I'm sure modern electricians have like I've got a bloody wire stripper that you can set to different depths and everything, but yeah, so I'm going to try it a different way in this case, being very ultra careful not to nick the bloody insulation, which I did again on the second attempt. So this mains lead is getting fucking shorter by the minute. Right, let's have a look. Have I nicked any insulation? No, I haven't. Right, or have I? No, I haven't. Thank giddy goodness for that. Right, the wires are a little bit shorter than whatnot. Let's see where that. Always go off the earth lead. Yes, that'll go. Right, I shall carry on with that. You don't want to see me fit a plug, do you? So later. So this morning it's a game of playing find that capacitor. despite having quite a few capacitors. More over there, more over there, more over there, more over there, more over there. Have I got, squeak, two 150 picofarad capacitors of a 500 volt rating, or you know, a high voltage rating? And the resounding answer is no. Bit of a detour there into trying to prototype a output buffer for the preamplifier if needed, but it just goes to show you the sort of problems you can encounter if you pull like a sort of random schematic off the internet like I did, trying to get the thing to work. And the mistake I made primarily was not taking into consideration the current gain of the transistor and a few other things, but it's all a good learning experience. Hopefully you learned something from my mistakes. In the next episode I'll try to get the feedback circuit of the preamplifier working so that we actually can start getting some signals out of the thing without all the sort of chaos that we've had in the past. Thank you very much for watching. Take care of yourselves. Ta-da for now.